Fazil, we were doing free fall, right?
Yes, sir.
Free fall. We have discussed sign convention and everything. Sania,
Uh,
let's start with a very basic numerical. We haven't done any numerical on free fall, right?
No.
Okay. So let's start a basic numerical. It says, this was even in class 9. I'm taking this numerical from class 9 too.
Okay, sir.
Let's take a body of mass m. I projected this body upwards with a velocity of 10 meter per second. This is the given data. A body is projected upwards with velocity of 10 meter per second. It's projected upwards with a velocity of 10 meter per second. Calculate first part. Velocity of the body at the highest point. Velocity at highest point. Second, you're supposed to calculate time taken to reach highest point. To reach highest point. Third, displacement covered up to highest point. Displacement covered up to highest point. Fourth, I need time taken to strike the ground right from the highest point. To strike ground from the highest point. From highest point. Fifth one, I also need velocity with which it strikes the ground. Velocity with which body strikes the ground. Let's solve this numerical together. So what is the initial velocity with which body is projected? This body is projected with a velocity of 10. Its initial velocity is 10 meter per second. So its initial velocity u is plus 10 meter per second. That's the initial velocity. When this body reached the highest point, at highest point, the body came to rest. If I throw this case upwards, then it will travel up to a highest point, and at highest point, it will come at rest for a moment. For a second, it will come at rest to the highest point, and then it will come to the ground. This is the motion of body, right? If I'm throwing this body is upwards, it will travel to a maximum height. It will stop at the maximum point height for some moment, and then it will come back to the ground. So at the highest point, since the body stops, so the velocity at the highest point is 0. So the first part of the question, velocity at the highest point is 0. So B is 0. Second part of the question, time taken to reach highest point. So I'm consider, let's call this point as A and say this point as B. We are considering the motion from A to B. See, whatever you will learn in each and every part of this numerical, you will apply in the whole topic. The whole of free fall is based on these five parts. If these 5 parts are very clear, then you won't have any issue in numerical. So that's a very, very basic things. So if I'm moving a body from A to B, then initial velocity is 10 meter per second. In free fall, the acceleration is minus of g. It's minus of 10 meter per second square. Fatima Farhana and Fatima Sharif, feel free to ask questions. If you didn't get anything, just keep asking.
Okay, sir.
So U is plus 10 meter per second, A is minus 10 meter per second square. I need time taken to reach maximum height, and velocity at the maximum height is 0. Sania, out of
Sir, I got the answer.
out of 4 equation of motion, which one would be most appropriate to calculate time?
V is equal to V is equal to UT plus 18. GT means 80. Same.
V is 0, your U is 10, your A is minus 10, and this is T.
1 second.
Oh, basically G is not minus 10. The exact value of G is minus
10 meter per.
9.8 meter per second square, and that's almost minus 10 meter per second square.
10.
So it's minus 10 into T. You can write this as 10T equal to 10, or you can write this T as it's 10 by
1 second.
so time will be constant. So this is the time which this body takes to reach the maximum. So that's answer of part 2 of the question. Okay, just note it down. Then we'll start with part 3, part 4, and part 5. Done. Okay. So shall I raise it? Written?
Yes.
Yes, sir.
Fatma?
Yes, sir.
Both Fatma. Fatma Sharif as well as Fatma Farhana. Written? Okay, what's the third part? Fazil,
Sir, displacement.
displacement. So Fazil, which one is most appropriate equation to calculate that displacement?
V square minus U square by 2G is equal to
Square minus 2s. Always remember this V square minus U square is 2s, not in terms of G. If you remember this in terms of G, then in sign convention, you can make some mistake. So it's V square minus U square is 2s. Your U is, it's plus 10 meter per second. It's the highest point, so velocity is 0. Your acceleration is minus of G, which means minus of almost 10 meter per second square. And this S that you have to calculate. By substitute all these values, it comes out to be 0 square minus 10 square is 2 into acceleration, which is minus 10, multiplied by displacement. So this is minus 100 is minus 20s. So S comes out to be
5.
yes.
5.
Yes, Sanya. You're asking something?
No, sir.
So this is the displacement that it will cover to travel up to maximum height. Fatma Sharif, are you getting this thing? This numerical?
Yes, sir.
And Fatima Farhana, are you following or not?
Yeah, sir.
So fourth part. What's the fourth part? Noor.
It's time taken to strike the ground from the highest point.
Time taken to strike the ground. So I'm considering motion from B to A. It's time taken to strike the ground. That means we have to consider the motion from B to A. If we are considering the motion from B to A, then Noor, what's the initial velocity?
So it's 0 meter per second.
0 meter per second. And what about the acceleration?
10 meter per second square.
Minus, right? It's minus 10 meter per second square. What about the displacement that body will cover? From A to B, it comes out to be 5 meter. Then what should be B to A?
5 meter.
Noor,
Minus 5 meter.
the displacement covered.
So it's minus 5 meter.
Yeah, it's minus 5 meter. The displacement covered is minus of 5. You are supposed to calculate the value of time. So which is the most appropriate equation? Good.
So S is equal to UT plus half AT square.
Okay, without calculating, can you guess what should be the value of time?
1 second.
Without calculating this thing, can you just directly guess what should be the value of time to take to strike the ground from the highest point?
So 1 second.
And right, because time of ascent should be equal to time of descent. So your S is minus 5, your initial velocity is 0, plus half, your acceleration is minus 10, it's into t square. So it's minus 10 is minus 10 into t square. So if your t square would be minus 10 by minus 10, if I cancel them, your t square comes out to be 1. If you take root, it's 1 second. So this body will take 1 second to strike the ground from the highest point. This is what we have discussed in the previous class in time of ascent and time of descent. Time of ascent is equal to time of descent. That means time taken to reach maximum height is exactly equal to time taken from maximum height to the ground. So that was part 4 of the question. Sania, what about part 5th? So what you're supposed to calculate?
Part 5. Velocity with which body strikes the ground.
Velocity with which body strikes the ground. So which one is the most appropriate equation to calculate that velocity? Yes, Sania.
Sir, your voice is breaking.
I'm asking which one is most appropriate equation to calculate this velocity?
Sir,
Audible? Am I audible? Fazil, Noor, Fatma?
Yes.
Yes, sir.
Okay, Sania. Sania, am I audible now? Okay. So the equation that we will use is v square minus u square is 2x. Just keep on substituting the values. Here u, if you are considering your motion from B to A, then B, initial velocity is at point B, which comes out to be 0. Your acceleration is minus of g, which is
sir, I can
minus 10 meter per second square.
properly.
Am I audible, Sania? No? No. The displacement from B to A, the displacement from B to A is minus of 5 meters. If I substitute all these values in this equation, then this is v square minus 0 square is twice of acceleration, which is minus 10, multiplied by displacement, which is minus of 5. So v square is 100. And your v comes out to be root over 100. V comes out to be root over 100. So it's plus minus 10 meter per second. So which one should I prefer, plus 10 or minus 10? Puzzle.
Minus,
Why?
sir, because it is falling from initial.
Right? Because yes, minus, because it's going downwards. So your velocity is simply, it's minus of 10 meter per second. This is velocity, minus 10 meter per second. So all 5 parts clear?
Yes, sir.
Yes, sir.
So Fatma, you're getting everything?
Yeah.
Farhana, even if you are not getting all this physics, why I'm using this v square minus u square is 2s, since you haven't done these concepts, so maybe you may not be getting why I'm using these equations. But for today, at least, try to concentrate on calculations. For the calculations that I'm using, this square, division, multiplication, this is, you must be comfortable with these calculations. So don't worry why I'm using this equation. Instead of worrying about these equations, try to concentrate on calculations.
Yes, sir.
After just 2 hours of backup classes, you will be as per the class speed.
Okay.
2 hours of backup class, you will understand everything. But for the timing, just concentrate on calculations.
Okay, sir.
And just let me know when you have written. I will rub it up, move on to next numerical.
Okay.
Let me know when you are done. I will rub it up.
Sir, finished.
Finished, okay? Sani,
Done, sir.
Fatma,
Sir, finished.
finished. Okay. Let's rub it and move on to next numerical. So let's raise the standard of numericals a bit. The next numerical says a ball thrown upwards with a speed of 19.6 meter per second from top of a tower returns to the earth in 6 seconds. Find the height of tower. See. So this is the tower. The height of the tower is 19.6 meter. This is the height of the tower, 19.6 meter. From the top of this tower, I projected a ball upwards. Okay, so height is not known, that's velocity. Height is that we are supposed to calculate. The body is projected upwards with some initial velocity of 19 meter per 0.6 meter per second. We can guess the motion of body, right? If you throw a body from the top of the tower, what would be the motion of the body? This body will travel up to the maximum height. It will stop there for a moment and then it will finally come back to the ground. This is the motion of the body. If you throw the body upwards, it will travel up to the maximum height. it will stop at that maximum height for movement, and then it will finally fall to the ground. And in this whole motion, you're supposed to calculate the total height. The initial point is A, and the final point of the motion is B. And the time taken from A to B is 6 seconds. So to solve this equation, I need initial velocity, which is very clear, which is 19.6 meter per second. I need acceleration, which is, as in all cases of free fall, it's always minus g, it's almost minus 10 meter per second square. Okay, what should be the displacement? I need answer of each one of you. Just report your answer in chat room. What do you think should be displacement? This height is h, this is h, and let me call this as h1. What is displacement from A to B? I'm considering motion from A to this some point h and then to B. The motion is from A to a highest point h and then back to B. I need displacement. Displacement from A to h and then h to B. What is displacement? I need answer of each one of you. Just report your answer in chat room. If I throw this body from A, it travels up to h and finally strikes the ground at point B. This height is h, this height is h1. What is displacement? Displacement is the shortest path between 2 points. I need S, which is displacement from A to B. Don't calculate, just write your answer in terms of H and H1. Okay. Okay, Sania. And what about the rest? I need displacement from the entire motion A to H and H to B. What's the total displacement from A to B? I got only one answer from Sania. What about the rest? The rest 4.
So we should calculate the answer.
No need to calculate it. Just report your answer in terms of H and H1. That's it. I will calculate the whole thing. Just write what is displacement in terms of H and H1. That's it. Don't calculate H. Sania says it's 0. Is it H? Is it H plus 1? Is it 0? Or is it H plus 2H? Or whatever.
Sir,
Yes.
you are talking about the displacement or the height of the...
I'm asking about displacement. Displacement. No answers, huh? Okay. Fazil says H1 plus BH. Fatma? Displacement means shortest path between initial and final. That's it. Displacement is nothing but the shortest path between initial and final. Fatma Sharif, Fatma Farhana. No answers. Okay. So the correct answer is it's H. It's not H plus H1, not it's 0, it's H basically. See, what is displacement? The shortest path between initial and final. While calculating displacement, we don't care about the total path. We don't care about the total journey, entire journey. What we care about is just the initial and the final point. So when I throw this body from A, then the initial point is A and the final is B. That's it. When I'm asking you to calculate displacement, then don't worry about the entire journey. Just worry about the initial and final position and move from initial to final. So Sani, if I'm moving from initial to final, what's the shortest path? How much is the shortest path?
H1.
H1 or is it H? I'm moving from just from initial to final. This is initial and this is final.
H. H.
This is H only. So displacement is H in this case. When we calculate displacement, we don't care about the entire journey. We only care about the initial position and the final position. Your displacement is the shortest path between that initial and final position. So how much is that displacement? Is it plus H, minus H? What is it?
minus
because while moving from initial to final, you are going downward. So displacement is minus.
minus h.
And the total time taken is 6 seconds. So the most appropriate equation that I guess is ut plus half at square. Okay, just substitute these values in this equation and get the value of h. Substitute all values in this equation and get the value of h. Fatma, Fareen, Sharif, Farhana, just do these calculations. Substitute value of u, which is 19.6. Put value of t, which is 6. Put a, which is this minus 10. And s, which be minus h. Try to calculate h. This time I'm expecting answers of all in chat, all 5. Answers. Okay. Okay, Faisal, we'll check it. It's 58.8, okay. I got just one answer from Fazil only. Okay. I got answers from Fazil and Noor. What about the rest? Speed up your calculations. It's simple multiplication and then square. Okay, Sania. Fatma is just multiplication. Substitute the values. Okay. Very good. Fazil, you are making some mistakes. Otherwise, everyone is getting the right answer. So U is 19.6. You're making some calculations mistakes. T is 6.
No, I took 9.8.
9. Okay, you take 9.8. Fine. That's minus 10 into 6 square. If I substitute these values, it comes out to be 62.4. It won't be minus of 62.4. Minus minus gets cancelled out. It would be 60.4. So this is the height, 62.4 meters. So is it clear, right?
Yes, sir.
Yes.
So can I erase it?
Yes, sir.
Let's move on to next one. And please don't hesitate while asking questions. This subject of physics, you learn by asking questions, by discussions. Rather than by just listening the lectures, you learn this subject by constant discussions. That's why in physics, recorded lectures are not very successful. These discussions are important. Okay, let's move on to next numerical. The next numerical says, a balloon is ascending at the rate of 9.8 meter per second at height of 39.2 meter above the ground. When a food package is dropped from the balloon, after how much time and with what velocity does it reach the ground? Does it reach the ground? Okay, just a quick question. Say, apply a logic in this question. It's a balloon. This balloon is going upwards with some velocity, initial velocity. If I drop a food packet from this velocity, what do you think? What would be the motion of the packet? If I drop this packet from a balloon which is moving upwards, then packet will follow this path. It will, once you drop this packet, it will move downwards, or this packet will move in this way. First, it will go upwards and then down.
It will go downwards.
Downwards directly.
A or B?
A.
A.
All says A. A balloon.
Yes.
Upwards, I drop the packet from the balloon. So you're saying that that packet will go straight downwards, or first will go upwards and then downwards?
Downwards.
It will go downwards.
Can you repeat the situation once again?
There is one balloon. See, this balloon is going upwards with certain velocity. Someone from this balloon dropped a food packet. I'm just asking, what would be the path of the food packet? Does this packet move directly downwards, or first it will go upwards and then downwards? A or B? It's simple logic. No calculation, no physics, no maths, nothing. Simple logic. Just report your answer in chat room. A, B, A, B, A, B. Just report your answer in chat. No answers?
Sir,
Yes.
the person is throwing with his hand, or like the packet fly.
He's just dropping that packet from his hand. He's just dropping that from his hand. He just take his hand out and drop the packet from his hand. See, the correct trajectory would be B. Fatima is correct. The trajectory would be B. See, if the balloon were at rest, the initial balloon is at rest, and I drop the packet from the balloon, then the problem would be like this. This is a balloon, that's my hand is the balloon. This is at rest, and I drop the packet from my hand. Then packet will simply move downwards. Then the trajectory would be straight downwards trajectory. But instead of stationary, if this balloon is going upwards. So when I drop the packet from this balloon, then that packet will have some initial velocity in the upwards direction. So the packet will first move upwards and then it will move down. I'm repeating it again. Say initially the balloon is at rest. If I assume that balloon is at rest and I drop a packet from the balloon, consider my hand as the balloon and this case as the packet. So if balloon is at rest, I am dropping the packet, then the initial velocity of the packet is 0. It will go straight down. then the trajectory would be trajectory A. But if this balloon is going upwards, then the initial velocity of this packet is upwards. So this packet will initially go in upwards direction and then it will go in downwards direction. First it will go in upwards and then it will go in downwards direction. So rather than A, the correct answer would be B. The packet will move first in upwards direction. If you drop the packet from here, first the packet will move in upwards direction to a maximum height where its final velocity becomes 0, and then it will start falling downwards. This is the packet. This is the packet. So now, this is initial point A and this is initial point, this is final point B. When you drop the packet, then balloon was at a height of 39.2 meters. When you just drop the packet from the balloon, this balloon was at a height of 39.2 meters. Can you guess the total displacement of the packet when it strikes the ground, A to B? I'm considering motion from A to H and then H to B. Can you guess the total displacement of the packet?
9.2.
39.2.
39.2.
Because it's again displacement, which is the shortest path between initial and final position. We don't care about the total journey. We just care about the initial point and the final point. So that is minus of 39.2 meters. That's the total displacement. Your initial velocity is upward. So the initial velocity is like 9.8 meter per second. Your acceleration, it's free fall. So it's minus of G, which is, I guess, 9.8. If you take 9.8 in this case, your calculations would be easy. I'm taking 10 just to simplify the calculation. The exact value is 9.8. If you take 9.8 in this calculation, maybe your calculations will be shortcut. You're supposed to calculate T and then calculate V. So to calculate V or to calculate T, I can use this equation as is known. Let's first use this equation. V square minus U square is 2x. Use this equation and get the value of V. Once you get the value of V from this equation, and substitute this V in this particular equation, U plus 8, and get the value of T now. And report your answer in chat room. Calculate these two values and report your answer in chat room. Answers. Answers. Fazil got some answer, okay? Fazil, what about the second part? Okay, Noor.
I'm doing.
Okay, then calculate time. After velocity, try to calculate time. Sania, Fatma Farhana, Fatma Sharif. Okay. Sania, are supposed to calculate V, na? It's root of something.
Sorry, sir. I forgot.
Okay, let's solve it. So it's V square minus U square is 2S. So it's V square minus U. U is 9.8. So it's 9.8 square is 2 into acceleration, which is 9.8, multiplied by displacement, which is minus of 39. So V square is, it's 2 into 9.8 into 39.2 plus 9.8 square. Right, so your V square is, I'm using calculator, it's very lengthy calculation. So 2 into 9.8 into 3.2, 2 into 9.8 into 39.2, it's 768.32 plus, it's 9.8 square, 96.04. If I add them, 768.3, it comes out to be 864.36. And your V is, its root over 864.36. So this is the velocity. Noor and Fazil, why were you getting root 8? Both were getting root 8. Yes, it's 864.36. Now, once you have got velocity, you can easily calculate time. V is U plus 80. And if I take the root of 864.36, it comes out to be roughly 29.4 meter per second. 29.4 meter per second. Then just substitute these values here and get the value of t now. Okay, let's solve it further. I won't do the calculation. Just put the value of v, put the value of u, a, and get the value of t. Substitute the values of v, u, and a and get the value of t. Substitute these values and get the value of time. Speed up your calculations. Okay, 2 seconds. 2 seconds. Fazil, Noor, value of time. 1 second. If I substitute the values, V is 29.4, by root, U is 9.8, A is 9.8 multiplied by T. And take this velocity as negative because it's going downwards. So take this thing as negative. So 9.8 T is 9.8 plus 29.4. Fatma got 9.26, okay? Let's check your calculations. So you're getting why I'm taking this as negative. You're considering downwards as negative. So this velocity will be, when you substitute it here, it will be minus of 29.4 meter per second.
Sir, I did a mistake there.
So that's 9.8 T is 29.4 plus 9.8. So 29.4 plus 9.8. I'm again using calculator. So that's 29.4 plus 9.8. That's 39.2. So time is 39.2 divided by 9.8. And it comes out to be 4 seconds. So in 4 seconds, it will strike the ground. So clear? These calculations are clear now?
Yes, sir.
You all were making some mistakes in calculations. Note it down, we'll do one more numerical on the same concept. So can I raise it?
Yes, sir. Done.
Fazil, good. Fatma,
Yes, sir.
Yes, sir.
Yes, sir.
just one more numerical. Parachutist bails out from an aeroplane. It's an interesting question. Basically a real life problem. Aeroplane, and after dropping, through a distance of 40 meter, he opens the parachute and deaccelerate at 2 meter per second square. If he reached the ground, with speed of 2 meters per second, how long is he in the air? At what height did he bail out from the plane? At what height did he bail out from the plane? Again, you solve this numerical together. So this is the aeroplane. That was at rest. At the time this parachute jumped from this plane was at rest. This man jumped from the aeroplane. What do you think? What should be the initial velocity of this man? This plane is stationary.
0.
Yeah. Now its motion would be straight downwards. It will move exactly in downwards direction. So let's call this as point A. After dropping through a distance of 40 meters. So he dropped by a distance of 40 meters. He don't open parachute up to this 40 meters. So up to 40 meters, you can consider this motion as free fall. Up to 40 meters, he doesn't open his parachute. Initial velocity is 0. It gains some velocity VB up to this point. After 40 meters, he opened the parachute. Now, can you guess when he opened the parachute, its velocity will remain same VB or its velocity will decrease? Once you open the parachute, then velocity will remain same or it will decrease it?
Decrease.
Because once you open the parachute, the air friction starts acting on this person. The air friction will act in upwards direction. So its velocity will decrease. That's why parachute is used. It's decrease the velocity of the falling body. So now we open the parachute. So once he opened the parachute, now the motion is not free fall. Because free fall means only gravitational force is acting on the body. But once you open the parachute, then along with gravity, some upwards air friction will act on the body. So up to this point B, the motion is free fall, then acceleration is minus of G now. But once you open the parachute, acceleration changes and is saying deaccelerate at 2 meters per second square. So can you guess the direction of acceleration now? When it was in free fall, the acceleration was acting in downwards direction. But once you open the parachute, force will act in upwards direction due to air friction. Can you guess the direction of acceleration?
It's upwards.
Because force and acceleration acts in same direction. If air friction is acting in upwards direction, then acceleration due to air friction will also act in upwards direction. That's 2 meters per second square. This is 8. And he strikes the ground with some velocity. When he strikes the ground, strike here with some velocity, with a speed of some 2 meters per second square. If I call this as C, then velocity at C is 2 meters per second. So it should be plus 2 or minus 2? Plus 2 or
Minus.
it should be minus 2 because motion in downwards direction.
Downwards direction.
We will solve this numerical into parts. First, we will solve from A to B. From A to B, initial velocity is 0. For A to B, the displacement is minus of 40 meters. For A to B, your acceleration is minus of G. Let's take it as 10. So it's minus of 10 meters per second square. Now, using this relation, S is ut plus half AT square. First, get the value of t, the value of time. And then use this equation V is u plus AT to get the value of V. Solve it. First, solve it from A to B and report your answer. I need T and I need VB. Just report your answer in chat room. Then we will solve it from B to C. You can use calculator if you want. But please calculate. Okay. Time 2 seconds and velocity you can find. Okay, let's check your calculations. So if I substitute the values, displacement is minus 40. Your initial velocity is 0. Your acceleration is minus 10. Then it's t square. So this is minus 80 by 10, which is t square. Minus 80 by minus 10. Gets cancelled out. So your t square is 8 and your t is root 8. So t is 2 root 2 seconds. So I guess Noor was correct. Fazil got the correct answer. Sania, it's not 2, it's 2 root 2. Fatma Sharif got the right answer. She just forgot to write the root. It's root 8, which is 2 root 2 seconds. And it would be better if you report your answer in every one column. Don't make private messages. Report your answer in chat room in this everyone column. So t is 2 root 2 seconds. Once you have calculated time, you can calculate velocity. V is u plus 80. Just keep on substituting the values. Initial velocity is 0. Your acceleration is minus 10. Your time is 2 root 2. So it comes out to be minus 20 root 2 meter per second. This is the velocity. Is it clear?
Yes, sir.
Fatma, Farhana, you are not calculating, huh? Okay. I'll just substitute these values and so this is velocity minus 20 root 2 meter per second. This is the velocity. After velocity, now solve from B to C. When we solve it from B to C, then the initial velocity is the velocity at B, which is minus 20 root 2 meter per second. Remember, when you're solving from B to C, the velocity at A is not initial velocity. Your initial velocity is now the velocity at the initial point, which is B. So it's not 0, it's now minus 20 root 2 meter per second. So I call this as U2. And your acceleration is plus 2 meter per second. And when it strikes the ground, then its velocity is given. What's the velocity on the ground? It's minus 2. Minus 2 meter per second. Now again, I need displacement in the time taken from B to C. Calculate it and don't make any mistake now. Use this equation like V square, or you can simply use this V is U plus 80. Yeah? V is U plus 80. Use this equation and get the value of time. And then use this equation ut plus half 80 square and get the value of displacement. Calculate it. And try not to make any silly mistake. Get the value of velocity and displacement. Answers. Okay. Fine. Noor got some answer. Okay, Fazil. Okay. Sania, Fatma. Just substitute these values in this equation. That's it. Okay. And what about displacement? Fatma, your answers? Okay, I'm solving it now. So when you write V is U plus 80, just substitute the value of V, which is minus 2. U, that's minus 20 root 2. acceleration, which is 2, then time is t. So it will be minus 2 plus 20 root 2 is equal to 2t. So this is minus 2 plus, I can substitute the value of root 2. Root 2 is 1.414. So let's keep it as 1.4, it's 2t. So if I multiply 1.4 into 20, it's minus 20 plus it's 28. That's 20 into 1.4, it's 14 into 228, which is equal to 2t. So this is 26 equal to 2t. Your t comes out to be 26 by 2. Your t comes out to be 13 seconds. Why we're getting 27 seconds? Fazil, Sania, Fatma, is it clear now? These calculations?
Yes, sir.
Yes, sir.
Okay.
I was having doubt with the root. Root 2.
So once you have got t, you can easily calculate b now, right? You can calculate displacement easily. Displacement is ut plus half at square. Okay, now substitute this value. And once you substitute these values, you will get your initial velocity is minus 20 root 2 multiplied by 13 plus half. Your acceleration is 2 into 13 square. So you will get somewhere around 197 minus of 197. Okay, just note it down. We are just left with one more type of numerical on free fall. Then we'll start something else. Is it clear now?
Yes, sir.
Yes, sir.
Remember these values. Root 2 is 1.414. Root 3 is 1.73. Let me know when you have written. I'll just erase it and we'll do one more numerical on free fall. The last numerical on free fall. So can I erase it?
Yes, sir.
Fatma, Sania.
Yes, sir.
Yes, sir.
So let's erase it. And the next question is, okay, before starting next numerical, answer this simple question. Say you have two persons, A and B. They start simultaneously from their home and they meet somewhere in between. May not be at the midpoint, they meet somewhere at, this is the meeting point. Both start simultaneously. Both start simultaneously means both starts from their home at the same time. Like if A left his home at 2 p.m., then the B left home exactly at 2 p.m. Both leave their homes at the same time. This is place of meeting. They meet over this point. Let's say they meet at 5 p.m. They can meet at 5 p.m. only if both reach at this point T at 5 p.m. simultaneously. The meeting is possible only if both reach the point of meeting simultaneously at the same time. So how much is the time taken by A to the meeting point?
5.
How much time will this A take to reach meeting point? It starts at 2 p.m. and reach at 5 p.m. How much time does A take?
3 hours.
3 hours. And what about B?
3 hours.
3 hours.
Yes.
In a numerical, there's something like collision of two bodies, and the question says simultaneously. If in question somewhere simultaneously is mentioned, that means time for both the bodies would be same. You will get problems in free fall when it would say is throw two stones simultaneously and then they collide. If stones are thrown simultaneously and they collide, this is possible only if both take same time to travel from initial to the point of collision. Always remember this result. If bodies start simultaneously, means T1 is equal to T2. Just note it down. We'll use this concept in the next video. And let me know when you are done. So can I raise it?
Yes, sir.
Last numerical on free fall. Two balls are thrown simultaneously. Balls are thrown simultaneously means for both the time would be same. A vertically upwards with speed of 20 meter per second from the ground and B vertically downwards from a height of 40 meter. With the same speed and along same line of motion. At what point do the two balls collide? Okay. So there are two balls. A ball A is thrown vertically upwards. This is ball A. This is ball A. It's thrown vertically upwards. And this is ball B. This is dropped from it. So this is ball A and this is ball B. Ball A is thrown vertically upwards with some velocity of 20 meter per second. Means its initial velocity of ball A is 20 meter per second. And ball B vertically downwards with the same speed. So that means B is thrown downwards with a velocity. Since this is downwards, so we'll take this as negative, minus 20 meters. They are thrown simultaneously, means that if he throws ball A, B at t equal to 0, he throw A at t equal to 0. They collide somewhere. let's say they collide at this point somewhere. Ball A and B collide over this point. The total height between these 2 points is 40 meter. Let's say this is B and this is A. They collide over this point and this separation is X. So Sania, can you guess how much is this? The total is 40, this much is X, then how much should be this one?
X minus 40. X plus 40.
40 minus X.
40 minus.
40 minus. Total is 40. This much is X, so it would be 40 minus X. So you're supposed to calculate this X. Now, can you guess time taken by B and time taken by A? It would be same or would be different?
Same.
It would be same. So time taken by A is T, time taken by B is again. So the time taken by both the bodies is same. It's T1. Okay. Let's solve first body A. For body A, let's use this equation. S is ut plus half AD square. So body A, S is positive 40 minus X because body A is going upwards. The initial velocity of body A is plus 20 meter per second. And the time taken by body A is T only. If I substitute all these values here, you will get 40 minus X, it's 20T plus half. Your acceleration is minus G into T square. That is your first equation. This is for body A. Just note it down and then try for body B. I don't have space, and just let me know when you have written this thing.
Done, sir.
Okay. I'm erasing this question. Now, if I write the same equation for body B, since body B is going downwards, I'm writing the same equation for body B. It's ut plus half AD square. So your S is minus of X, it's going downwards, so displacement is negative, it's minus X. Your acceleration is minus G. Let's keep it as minus G now. The time taken is by B is again T. If I substitute all these values here, this is minus X, and obviously your velocity it's given as minus 20 meters. So it's minus 20T minus half GT square. That is equation number 2. So that's 1 and this is 2. Using these two equations, you are supposed to calculate the value of T and X. So if I substitute from this equation 2, I can get the value of X. So this negative sign will cancel out from the whole equation. This is 20T plus half GD square. That's 2. Okay, now do this calculation. Just substitute 2 in 1 and get the value of time. Do this thing. Substitute 2 in 1 and get the value of t. And report your answer in chat. Substitute these values. Just substitute 2 in 1 and get the value of time. One second, okay? Good, Fazil. Now substitute this in equation number 2 and get the value of x. Once you get the value of time, Fazil is correct, it's t equal to 1 second. More answers? Noor, Sania, Fatma. Okay. Okay, if I substitute equation number 2 in 1, very good. So that's 40 minus x, which is 20t plus half gt square, which is 20t minus half gt square. So this is 40 minus 20t minus half gt square is 20t minus half gt square. Minus half gt square will cancel this minus half gt square. You will get 40 is 20t plus 20t. So we'll get 40 is 40t. So we'll get t equal to 1 second. This is t equal to 1 second. Once you get t, put t equal to 1 second in equation number 2. If you substitute these values, you will get x equal to 20 into 1 plus half g, which is 10 into 1 square. So you'll get x is 20 plus 5, it comes out to be 25. Fazil, don't substitute g equal to minus 10 here because we have already considered the sign of g here. We have already considered a negative sign. So here only substitute the value. Noor, is it fine?
Yes, sir.
You didn't get t equal to 1 second.
I got it, but I forgot to type in the chat.
Yes, 25 meter. Fatma, Farhana, is it clear? All these calculations?
Yes, sir.
So can I erase it? Sure. So that was about free fall. After free fall, the next topic is relative velocity in 1D. Relative velocity in 1D. See, up to free fall. See, motion is not absolute, motion is relative. The velocity of a body depends on the place of observer. Motion is relative. Let's prove this thing from an example. Let's say I have is a car A. It's moving with some velocity of 10 meter per second. There is one observer on the ground. This is observer on ground. This is observer on ground. When this observer observes this car A, he would say that car A is moving with a velocity of 10 meter per second. So I can say that velocity of car A with respect to ground is 10 meter per second. So velocity of car A with respect to ground is 10 meter per second. This is 10 meter per second if your observer is on the ground. Now say your observer, this is again your common sense, no physics, no mathematics. Your observer sit over a car which is moving in the same direction with the velocity of 5 meter per second. Okay, now guess. Will velocity of car A with respect to observer on car B would be again 10 meter per second or it will change?
It will change.
The observer in car B, when you observe this car A, it will observe the same velocity or its velocity will change?
Yes, it
Change.
will change.
Velocity will decrease in. When this observer at B will observe this car A, so velocity of car A with respect to observer in B is not 10 meter per second. Is if instead of 5, let's take another number, let's call it as 6. Is 10 minus 6, which is 4 meter per second. So car A is one car, it's moving with a velocity 10 meter per second. But its velocity with respect to an observer on ground is 10. But the velocity of same car with respect to another observer who's moving in car B is 6 meter is 4 meter per second. So motion is not absolute. The motion is relative. Motion is relative. With respect to one observer, this is 10 meter per second. With respect to another observer, this is 4 meter per second. It's 4 meter per second. So this is how we calculate relative velocity. So till now, whatever numericals we have done, we have always calculated velocity with respect to ground. But from now onwards, he will ask you to calculate velocity, acceleration, displacement with respect to a moving observer, in another observer. So this was an example for relative velocity. Say you have a body A. Okay, just note this example. I will rub it up and then we will start relative velocity. And let me know when you have written it. Okay.
Done, sir.
So can I raise it?
Yes.
So let's write some formula to calculate relative velocity. Say this is body A. It's moving with a velocity V. So this VA velocity is with respect to ground. You have another B. It's moving with a velocity V. These two velocities are with respect to an observer on the ground. So what is VA? And obviously velocity is a vector. So VA is velocity of body A with respect to ground. So VB is velocity of body B with respect to ground. So with respect to ground, the velocities of body A and B are VA and VB. If I put an observer on B, and if I try to calculate velocity of A with respect to an observer in B, then we write this as VAB. VAB is velocity of body A with respect to an observer in B. Or we simply write this is velocity of body A with respect to B. Okay, just tell me, if an observer is on ground, then he will observe that both A and B are moving. But I put this observer on body B. How would he observe body B? According to him, body B is moving, or it comes to rest. So if your observer was on ground, then with respect to this observer, both A and B are moving. But if I put this observer on body B, then with respect to this observer, body B is at rest or is in motion? Yes. With respect to B, with respect to this observer who is sitting on this body B, the body B would be at rest or in motion?
It will be at rest.
It could be at rest. Say if you are standing on the ground and a bus is moving with a speed of 100 km per hour. If you're on the ground, you'll observe the speed of bus to be 100 km per hour. But once you sit in that bus will come to rest with respect to you. So if your observer is in B, then I can write this as this is velocity of A, velocity of body A with respect to, body A when B is at rest. I'm repeating it again. When B is at rest doesn't mean that your body comes to rest. It simply means that this velocity is with respect to an observer who is in body B. This is with respect to an observer who is sitting in body B. Body B is moving, but this velocity is with respect to an observer in body B. So that body B is at rest with respect to this observer. So these are the velocities. If you want to calculate velocity of A with respect to B, the simple formula is simply velocity of A minus velocity of B. But this subtraction is vector subtraction. You're supposed to use parallelogram law to subtract these two vectors. This is a vector subtraction. But if you say that motion is one-dimensional, but if you say that your motion is 1D, it's one-dimensional motion, then you can simply write this as VAB as VA minus. If you say your motion is 1D, then no need to do the whole vector subtraction. You can simply subtract them algebraically. So you can write your VAB as VA minus VB. Simple algebraic subtraction. But while using this subtraction, you should use sign convention. Sign convention simply says if you consider one direction as positive, then the opposite would be negative. Means if V1 is acting in this direction and V2 is acting in this direction, if you're saying that V1 is positive, then take V2 with a negative sign. That's relative velocity, that's it. So velocity of A with respect to B is velocity of A minus velocity of B. So where is your observer when you are calculating VAB? Your observer is on ground, on A or on B? Yes, where is your observer if you are calculating VAB? Your observer is
B.
on A or on B?
On B.
On B. When you're calculating VAB, your observer is on B. Just note it down. Is it clear, Sania, Fatma, this concept of relative velocity?
Yes, sir.
Just let me know when you have written.
Sir, done.
Yeah. So can I raise it? Noor, Fatma.
Yes, sir. Done.
Let's rub this thing. Now, along with velocity, you can have relative acceleration too. In fact, in some numericals of NCRT, you will use relative acceleration. So, relative acceleration of A with respect to B is simply acceleration of A minus acceleration of B. That's a relative acceleration. And you can have even relative displacement. If velocity is relative, then everything is relative. Relative displacement. Displacement of A with respect to B. Fatma Farhana, can you guess how do you how to calculate this SAB displacement of A with respect to B? Fatma Farhana, can you guess the formula of SAB if AAB is A minus AB? Okay, at least try. If acceleration of A with respect to B is acceleration of A minus acceleration of B, then what should be displacement of A with respect to B? Okay, Fatma Sharif, will you try? No. Fazil,
Yes, sir. SA minus SB.
that's simple. Displacement of A
Minus displacement.
minus displacement of A. Just note it down. We'll do some numericals on relative velocity. Okay. So can I raise it?
Yes, sir.
Yes, sir.
This question is in NCRT. So two trains A and B move on parallel straight tracks as shown in figure. So you have two trains, a train A and a train B. This is north, this is south. Train A is moving towards north and B is moving towards south. A is moving with 100 meter per second and B is moving with 40 meters per second. Calculate first part. Velocity of A with respect to B. Second part, velocity of B with respect to A. Third part. A monkey is running on roof of train A with velocity of 5 meter per second, or not 5, velocity of 10 meter per second towards north as with respect to train, with respect to observer in training. Calculate velocity of observer with respect to ground. Calculate velocity of observer with respect to ground. Observer with respect to ground. So you're supposed to calculate the velocity of observer with respect to the ground. So let's solve this calculation. So if I consider this direction as positive, I'm saying this is the positive direction, then this would be negative. If I'm saying north is positive, then south is negative. There's nothing special about north. You can as well take south as positive, so north will become negative. This is convention, whatever you follow. So I'm considering VA as plus 100 meter per second. So your VB will be minus 40 meter per second. For part A, he asking you to calculate VAB. So Fatma Sharif, what's the formula of VAB? Fatma, formula of VAB. You're not audible, bache.
BA plus BB.
It's yes, Fatma, now you're audible. So what is VAB? Fatma, you can just type your answer in chat group. VAB will be VA minus VB. In the second part, he's asking you to calculate VBA. That will be right. VB minus.
A minus VA.
In the third part, this 10 meter per second is not velocity with respect to ground. This is velocity with respect to an observer in train. So Noor, what is this 10 meter per second? This is VA, VB, VM. What is this?
It's VMA, right?
Yeah, it's velocity of monkey with respect to it. It would be positive or negative?
Positive.
Positive. See, this 10 meter per second is not with respect to ground. It's a monkey which is running on top of train A with a velocity of 10 meter per second with an observer in train A. So observer in train A will not observe the absolute velocity, will observe the relative velocity, which is plus 10 meter per second. That's VMA. VMA is plus 10 meter per second. So you are supposed to calculate VMA. Attempt all these three parts and report your answers in chat. All. Repeat all three parts and report your answer in chat. Whatever the answer you are getting, just report it in chat. Calculate all these velocities and record your answer in chart. Okay, fine. All three parts. Good. Okay, good. Now check your calculations. Good. So VAB is it's 100 minus 40. So it comes out to be 140 meter per second. If I solve VB minus VA, so VB is minus 40, VA is minus 100. So that's minus 140 meter per second. In part 3, we write VMA as VM minus VA plus VA. So VM is VMA. VMA is 10 plus VA, which is 100. So VM is 110 meter per second. Means with respect to an observer on ground, this monkey is running with a velocity of 110 meter per second. And with respect to an observer in the train, its velocity is 10 meter per second. So is it clear?
Yes, sir.
Okay, just I'm adding one more part in it. Calculate velocity of monkey with respect to train B. No hint. Solve this one. Velocity of monkey with respect to train B. Answer is velocity of monkey with respect to train B. Okay. What about the rest? Okay. Fatma. Let's calculate it. Monkey with respect to B is velocity of monkey minus velocity of B. Velocity of monkey is not 10. 10 is monkey with respect to A. Velocity of monkey is 110. One we have calculated in part 3. So monkey with respect to B is 110 minus. How much is VB? VB is minus 40. So it's minus of minus 40. So that 110 plus 40, which is 150 meter per second. Is it clear?
Yes, sir.
Yes, sir.
Fatma? Tell me you still have any doubt in it, why I'm taking 110 and not 10. Tell me very frankly if you have still any doubt in it. See, every numerical is based on the previous one. If you miss this part, then the next part would be an issue for you. Is it clear? Fazal, Fatma? Because Sania and Noor were getting the right answer. Okay, so let's stop here. We will continue. This relative velocity is almost finished. We'll do some more numericals on relative velocity. And then we will start this chapter number 4. Then we'll do chapter number 4. Or we can skip chapter number 4 because someone was telling me that your school teacher have just did that vectors in chapter number 4.
Yeah, we did only
Yes.
vectors.
So for the time being, we can skip projectile and jump directly to laws of motion.
Okay.
And then we will, once we just match the pace of syllabus with that of your school, we will come back to chapter number 4 and we'll complete the remaining part, right? That we can do.
Okay.
So next class is on Wednesday. On Wednesday, we will finish it up. And hopefully I will start chapter number 5.
Okay, sir.
Okay, let's stop here. And Fatma, I will start backup from Thursday on. The backup classes will start from Thursday. Continue on Wednesday. Start on backup. All you backup from Thursday.
Okay, sir.
Okay, Allah Hafiz. Stop here.
Yeah,
Thank you, sir.
thank you. Allah Hafiz.
Thank you.